Go wherever you may on the globe today, and where you find Ford cars, you will find Ford service. For just as the Ford Motor Company was the pioneer in the making of a strong, simple, satisfactory automobile at low price, so it was also the pioneer in establishing complete and satisfactory service facilities. Such a policy could only be conceived in a mind more intent on helping the public to see the value of the automobile than on making profits. The car itself as a helper of the people, has always been first in Henry Ford's mind, and never was it expressed more strikingly than it is today in the V8 cylinder Ford car, a new and outstanding value at low price. This new V-type 90-degree engine develops 65 horsepower. Like all other Ford engines, it is simple in design and construction, and it is remarkably smooth in performance. Just as Ford's sales and service extend throughout the world, so the Ford Motor Company is ever seeking everywhere for ways and materials to improve its products. One of the latest enterprises of the company is the development of a rubber plantation in Brazil. Here at Boa Vista on the Tapajos River, a tributary of the Amazon, Ford is pioneering the rubber field, clearing jungles, planting rubber trees, and bringing a new outlook on life to the natives. More than 5,000 acres of land already have been cleared, and nearly all of it planted with rubber trees. Ford industries abound throughout the United States. In Kentucky and West Virginia, the company has its own coal mines to provide a uniform quality of coal for the vast coke ovens at the Rouge plant. From mine to plant, the coal is transported by the trainload. It goes into the coke ovens to be converted into coke, gas, tar, oils, and other byproducts. Ammonium sulfate, one of the byproducts, is widely sold as a fertilizer. The company has protected itself against possible timber shortage through acquisition of approximately 500,000 acres of timberland in northern Michigan. It has its own logging camps and its own sawmills and dry kilns, supplying millions of feet of lumber needed for the Ford industries. Again, in northern Michigan, Ford iron mines give up their treasures, supplying thousands of tons of ore for the blast furnaces at the Rouge plant. Ford-owned freighters ply the Great Lakes, bringing cargoes of iron ore, sand, limestone, coal, and lumber to the Rouge plant, raw materials that are soon transformed into finished parts for Ford cars and trucks. Here and there throughout the United States are small Ford manufacturing plants. At Hamilton, Ohio, a hydroelectric plant produces wheels for Ford cars. At Green Island, New York, another hydroelectric plant produces other Ford car parts. And nearer Dearborn, along the Little Rouge River, smaller plants, all of them hydroelectrically operated, make thousands of Ford parts and tools daily. Among the more interesting is a Waterford plant, which supplies gauges to the manufacturing departments, gauges all made to the most exacting precision limits, and in some cases accurate to within 4/millionths of an inch. Another of these interesting little plants is this one at Plymouth, where taps are made, tools for cutting internal screw threads, such as in nuts. They are turned out by the thousands daily and in a variety of sizes. And now we approach the great Rouge plant at Dearborn. Let us pause for a moment for a glimpse of the engineering laboratory. It is here where new Ford cars are created, and where, under the personal direction of Henry and Edsel Ford, engineers are constantly at work developing means and materials for improving Ford products. Now here we are at the Ford Airport and the airplane plant where the giant all-metal tri-motor monoplane transports are built. Let us board one of these big airships and have our first view of the Rouge plant from the air. There it is below us, the greatest industrial center in the world. Steel mill, blast furnaces, foundry, glass plant, powerhouse, motor assembly building, and vast machine shops and manufacturing plants. Back to Earth, we enter the Rouge plant. Here the wonders, the precision, the advantages of the mechanical age find their most modern exemplification. Along the docks, giant unloaders reach deep into the holds of the Great Lakes freighters and bring up tons of iron ore, and all controlled by the simple movement of a lever by the man in the operating cage. Ship's gear, with equal ease, lift loads aboard Ford boats, soon to leave with supplies for domestic and foreign assembly plants of the company. Mechanical wonders abound in the open hearth building. A lever is pushed and a furnace tilts forward, pouring its 100 tons of molten steel into the waiting ladle held by a gigantic electrically controlled hand, which carries it off to the pouring dish as easily as one might carry a pail of milk. Here in the glass plant, a mixture of silica sand, limestone, soda ash, etc., is dumped into a furnace and comes out molten glass to be rolled into a 400-foot ribbon, then cut, ground, and polished to make safety glass for Ford car windows and windshields. In the spring and upset building, we see springs in process of manufacture. This is how they are tested. Now we move into the press steel building. Here we see a giant press. Responding to the touch of a man's finger on a button, it exerts tons of pressure in stamping out the section of a car body. Everywhere about the plant are interesting mechanical scenes. In this department we find machines which automatically make small parts, almost uncanny in speed and in accuracy. Electric welders seam weld the two sections of the fuel tank into one piece as easily as cloth is sewn together on a sewing machine. Not far away in another building, this hydraulic shear crushes and cuts up salvaged metal scrap, which is later fed into the open hearth furnaces to make steel. In the steel mill, red-hot ingots are lifted from the soaking pits. They are first rolled into blooms and then into billets in the blooming mill. Later, they are reheated and rolled into bars in one of the merchant mills. And so one might go on and on from one mechanical marvel to another. Research and experiments are constantly in progress to find new and better ways of producing and improving parts and materials for Ford cars and trucks. Laboratories are located throughout the plant, each as closely connected as possible with its own type of work in the production department. Inspection and tests are carried on throughout the manufacturing process with the utmost rigidity. Jigs, fixtures, and production gauges are checked for accuracy with Johansen blocks, which are the standard of precision measurement for the world. These blocks are manufactured by the Ford Motor Company under the supervision of Mr. Carl E. Johansen, the inventor. Something like 1 million gauges must be kept in correct adjustment at all times. Now we enter the motors building. Vital parts of the motor are checked for accuracy in the rooms on the left, all of which are kept at an even temperature so that the utmost uniformity in metallic structure may be maintained. Now we shall see how parts for the new V8 Ford car are inspected and checked. First, the crankshaft. This Ford-developed machine measures the static and dynamic unbalance of the crankshaft. Once the unbalance is obtained, it is a matter of only a moment to determine the amount of metal necessary to be removed from the throes of the shaft to bring it into balance, and it must balance within 3/10 of an inch-ounce, an exceedingly close limit. This machine, operating somewhat differently, also checks the static and dynamic unbalance of the crankshaft. The camshaft is carefully checked for accuracy. On this specially developed gauge, the spacing of the cams and bearings is checked. They must be in their proper position within 10/1000ths of an inch. This gauge checks the rear bearing flange, and this one the location of the fuel pump plunger eccentric. Both are held true within 10/1000ths of an inch. Still another inspection of the camshaft. Here the contour of the cams is gauged. They are not permitted to vary more than 2/1000ths of an inch. Connecting rods, vital parts of the engine, are closely checked. The diameter of the piston pinhole must be held true within 3/10,000ths of an inch. Here, the big end of the connecting rod is weighed as a check on the dynamic balance. This is the gauge used to check whether the bore of the big end bearing is square with the face. Take little things like the piston pins. Here's where they are inspected. In this gauge, the pin is checked for length, 2 13/16 inches. The location of the ring groove is also checked here. The diameter of the piston pins is held true within 3/10,000ths of an inch, and no pin can be off weight more than 2 grams, the 14th part of an ounce. In this room we find an inspection of the pinholes in the piston. The diameter of the holes is held to a limit of 3/10,000ths of an inch. The weight of the piston is held within 2 grams. Now here's an interesting machine which removes the overweight. A scale on the machine is set to the overweight figure. The piston is placed in position. The machine started and metal chips bored from the inside drop into a cup. When the weight of chips equals the amount to be removed, the machine automatically stops. Now for a little assembly. You have seen a set of connecting rods, pins, and pistons. This is how the pin, piston, and rod are assembled and checked for alignment. And these assemblies are then carefully weighed and matched in sets. Flywheels are statically and dynamically balanced. On this machine, the operator determines the amount of unbalance in the flywheel, drills out the necessary metal to bring it into balance, and then gives it a final check. The limit is 2/10 of an inch/ounce. Split valve guides are made in perfect half circles, making them interchangeable. Here the halves are being lapped and gauged to bring them in half circles. Now we move to the foundry, where cylinder blocks and other parts are cast. Next, the foundry machine shop. Cylinder blocks coming from the foundry go to the big milling machines. In this one, the surface of the cylinder bank is milled, first a rough cut and then a finish cut, and the surface must be true flat within a limit of 5/1000ths of an inch. We move to the motors building again and to the assembly line. Assembly of parts into the block begins here. Valves are ground and are properly seated. The crankshaft is assembled in the block. Pistons and connecting rods are assembled. Rings are fitted on the pistons. Connecting rods from opposite cylinders are attached to the same crank pin throw and oscillated in special floating double area bushings. Valve chamber cover plate with manifold integral and cylinder heads are soon assembled. Next comes the oil pan. Then the transmission and the clutch are attached. The completely assembled engine comes off the line and moves on to the dynamometer department, where it is tested. We are now in the B building and at the final assembly lines. Here the new 4-cylinder trucks are assembled. On this line, the new V8 cars are assembled. First, the engine goes into the chassis. Then the dash is attached. Further along and from the balcony above, a body is lowered on the chassis. Then we come to the end of the line, and the final inspection has a material effect on the reputation of the Ford Motor Company and the Ford dealers. It therefore must be service of the highest quality, efficiently, cheerfully, and courteously rendered, so the customer leaves smiling.